If you've never seen something called a vector before, it's a mathematical concept which is very, very interesting. It folds in not just the bigness of a number. I'll draw something in terms of its bigness right here. See that arrow? That has a certain length to it. But when you talk about vectors, what you do is you fold in a different dimensionality where now this arrow can point in all sorts of directions, right? So the direction of the arrow is quite important. And that's what we get into with vector analysis. So let's talk about some of the basic algebra, like what are these things and how do we operate on them. What I've got in this problem is 3 times the vector u, okay, that's this guy right here, 3 times the vector u minus 2 times the vector v. Now, you might be a little uncertain about how these things are handled, but fortunately, a lot of what you've learned in algebra is still going to apply here. We can still do scalar multiplication and adding components just like you would expect intuitively. So the way I'm going to do this is I'm going to say, okay, here's my w vector, and this equals 3 times my u vector, which is 3 comma 4. And it's going to be minus 2 times my v vector, which is 1 comma 5. And now multiplication distribution works the same as if these were parentheses. They're not, but the rules work the same. So 3 times 3 is 9, 3 times 4 is 12, and that minus 2 gets turned into a negative 2 in here once I multiply, and a negative 10. So now if I multiply particular components together, this 9, or not multiply, add them together, this 9 with this 2, that's going to make 7, and then I have this 12 with this negative 10. That's going to make positive 2. Okay, so there's my completed vector. This is W. Now, sometimes you see these things not in component form, right? This was component form right here. Sometimes we see them in what's called principal vector form. Principal vector form makes it even easier. Now we have principal vectors I and j. Now let me be real clear about what I and j are. I is this vector, 1 comma 0, and j is this vector, 0 comma 1. And by using that definition, we can basically turn these vectors into kind of polynomials, like you're used to. So in this case, I would say the vector w equals 3 times the vector u. Now, remember what u is. That's I plus 5j. And let's see, minus v. So v is negative 2i plus 2j. Okay, and now it looks just like an ordinary polynomial. We're going to treat it the same way. This is the main advantage of principal vector form. A lot of people prefer it for this reason. So I've got 3i plus 15j once I do that first distribution, and then plus 2i minus 2j. And now we just group up like terms. It's like these i's and j's are just the normal variables we're used to. So this becomes 5i, and the 15 and the negative 2 combine to make 13j. And that's how we handle addition, multiplication, subtraction of vectors.